Acceleration and Newton's law of motion. So the lesson target for this lesson, acceleration and the three laws of motion. State Newton's law of motion. Compare and contrast the effects of force and mass on acceleration. And explain why action and reaction forces are not balance forces. So first, we need to know what do we mean by these three. So the acceleration, it is a measure of the change in velocity of a moving object. It measures the rate at which velocity changes. So for example, if you are from a stop, so it means you do not have velocity. So that is zero. Now, dahan-dahang nagmo-move yung iyong vehicle or yung car mo, then after several minutes, bumilis na yung takbo mo. So, we have the change in velocity wherein from zero or from you not moving, nagkaroon na tayo ng tinatawag na acceleration because you have changed your velocity. And velocity is a measure of the speed and direction of motions. So for example, um, a velocity is given 5 kilometers per hour north. There's a direction which is the north, so we are pertaining to velocity. And the last one is the deceleration. Remember, if the acceleration is negative, it is now called the deceleration. And we have a moving GIF here on our right side of the screen. As you can see, we have four different ball um, going down the ramp. Okay, so meron silang race or mini race na nagaganap. So as you can see, these balls reach the final or the finish line in different speed, no? So makikita natin, ang nauuna dyan is the brown one. Next is the blue. The third is the red. And the last one is the green. So as you can see, they have different velocity po, no? It is also their velocity is being affected with their weight or the mass they have. Okay, so let us move with our next slide. So we are now going to discuss the different laws of motion. So first we have the Newton's law of motion, the first law, which is known as the law of inertia. So in this law, this states that an object at rest will remain at rest and an object in motion will remain in motion unless it is acted on by an unbalanced force. All right. So according to the law of inertia or the law of Newton, which is the first law, if an object is at rest, it will remain at rest. All right? And then if the object is in motion, will remain in its constant motion unless you exerted an unbalanced force. All right? So for example, we have a ball here. This object is at rest. Alright? So, hanggat wala pong force na tumatama sa kanya, it will not move. Okay, now, we have here the player, no? So, the player kicked the ball. And as you can see in our illustration, the player is the force that is exerted to the ball to move. Alright, then nag-move na po yung ating bola. Now, this object is in motion and it will continue with its constant speed and direction unless may force na tumama pa rin sa kanya. So, in this case, meron tayong force sa ating fourth illustration. And the force is our net, no? Yung ating net po, yung nagbigay ng force sa kanya, kaya po siya ay huminto or nag-change ng kanyang speed. Alright? Okay. So, the first law, ayun, sabi nga natin kanina, it is called the law of inertia, wherein, again, the objects in motion will remain in its constant motion and the objects at rest will remain at rest unless there is an unbalanced force. So, look at this illustration below our slide. So we have objects, no? So objects with greater mass have more inertia and it takes more force to change their motion. So for example, we have here the greater mass, which is the 300 kilograms of metal ball. Ayan. And then, it was being pushed by this guy. Kung mapapansin nyo, medyo malaki yung ating tao. And obviously, it has more force. No? So, in this case, magiging madali lang sa kanya na itulak or bigyan ng motion itong ating object na ito. It is because po, meron siyang greater force. No? But, come to think of it, if for example, our second illustration has a bigger or greater mass, for example, this metal ball weighs 300 kilograms. And look at the boy. No, hindi naman siya ganun kalaki. So, ibig sabihin, maliit lang yung force na meron siya. So, mas mahihirapan tayong magkaroon ng or ibahin yung movement or pagalawin yung ating object na ito. It is because po, maliit lang yung ating force na po pwede nating ibigay. Alright? Let me just clean this. So what is inertia? So inertia is a property of matter by which it continues in existing state of rest or uniform motion in a straight line unless that state is changed by an external force. So look at the examples of our law of inertia. Okay? So imagine that you are here sitting and driving a car and then suddenly may tumawid or may tumawid na aso, ganyan. So, ang tendency niyan, magbibigay ka ng force sa car to stop. Mabibigla. It is because po, may tumawid, so ang tendency, ibe-brake mo yung iyong pedal and magkakaroon po ng change in motion. No? From mabilis, no? Mapupunta ka sa pabagal and until you stop. Because of inertia, you feel jerk when brakes are applied. By looking at our second example, think of yourself, you are standing on a bus na puno ng mga pasahero. So, pag rush hour, ganyan na ang eksena natin. Alright, ngayon, hindi ka nakahawak because you are balancing yourself. So, ano naman, neutral lang naman or what I mean is, yung motion naman po ng bus is constant. Until medyo bumilis siya or nag-apply siya ng brakes. So, ang mangyayari, magkakaroon po tayo ng change in motion and it will cost you na ma-out of balance or mag-fail ka na katulad ng nasa ating screen. Alright, so now we are going to discuss the Newton's second law of motion. And this law is also known as law of acceleration. Okay, so this law describes how force and mass affect acceleration. So this law states that the acceleration of an object equals to net force acting on the object divided by the object's mass. So this law is represented by this formula. So we have the acceleration equals net force divided by mass, or we have A equals F over M. Okay, now look at our picture again that is present in our slide. So as you can see, we have here a 40 kilogram mass of this one, and this 40 kilograms, 400 kilograms yung una natin. And the second one is the 40 kilograms. Yan. And then, yung ating man or yung ating person na tumutulak, the same lang. Okay? So, as you can see, if the force you have given, or if the mass of an object is greater, you need greater force. No? Now, if the mass is lesser, of course, you need less force. Okay. So look at the illustration we have for Newton's law of motion. So yung first natin, which is ito, you are pulling a 10 kilogram trolley, and then you are pulling two 10 kilograms na trolley. So this one has a total of 20 kilograms. So by looking at the picture, you will already know which one of them ang nagbibigay na mas greater na force, no? So, because of less lang yung kanyang, dito sa number 1, less lang yung mass ng kanyang hinahaltak, mas less yung force na ina-apply niya, no? While in number 2, mas greater yung mass ng kanyang hinahaltak, so mas kailangan niya ng greater force. Next, in our left side, look at illustration letter A. So as you can see, hinahalpak po niya itong trolley na merong mabigat na bagay. So in letter A, we have one mass and one force. So it results to an acceleration. For number 2, if it has only if it has lesser mass, but you exerted greater force, it would result to greater acceleration. No? And then for letter C, you have greater mass, but you have lesser force being applied. It means you have lesser acceleration. Okay, so that is for our illustration for Newton's law of motion for the second law. Now we have an example problem in solving Newton's law of motion or the law of acceleration. So as you can see, we have our formula before. So acceleration equals force over mass. All right, now if force is missing, you can illustrate the formula by using this triangle. All right, so just write letter A, for acceleration, F for force, and M for mass. Now, if letter A is missing, you will just cover it and you will find the formula F divided by M. Now, if the force is missing, just cover letter F and you will get the formula A multiplied by mass. Alright? And then, if mass is missing, you can cover up letter M and our formula would be F over A. Now, for the units. So, we have the units for mass, acceleration, and force. Okay. So, for a mass, for the second law of motion, we use kilograms. Okay. And for the acceleration, we use meter per second squared. And for the force, we are using kilograms, meter per second squared. Or it can be written as Newton. All right. So let us try to answer, even though we have an answer here, let us practice, no? Answering this first problem. So, what force must act on 50 kilogram mass to give it an acceleration of 0.30 meter per second? So, our mass is 50 kilograms and our acceleration is 0.30 meter per second squared. Now, if you substitute it using our formula, it is the same po, because it is just multiplication. So, you need to multiply mass and acceleration. So, we have 50 kilogram of mass and acceleration of 0.30 meter per second squared. So, if you multiply that, you will get 15 kilogram meter per second squared, or you can write it as 15 newtons, and you can also write it in 15 N. Letter N represents newtons. Alright, so that is an example for our law of acceleration. Alright. Next, we have another problem here. So, our example, F is the force and its unit is Newton. M is mass and it has the unit kg. And acceleration has unit m per s squared. So you need to find acceleration for this problem. So our missing is acceleration. Now, based on our illustration, we have a force of 20 newtons and the mass of 5 kilograms. Okay. Now, what is our formula in finding acceleration? So, from our triangle, we have our formula in finding our acceleration based on our slide before. So, we have here acceleration is missing. So, you need to divide force and mass. All right. Now, let us substitute. So for force, we have 20 newtons. Now, we need to use the other unit so that we can cancel out, no, the same units. So don't be confused because kilogram meter per second squared is also newtons, or it is an equivalent unit for newton. And for our mass, we have 5 kilograms. All right, now let me just write the answer here. So you need to cancel out the same unit. So we have 20 divided by 5, that is 4. So our acceleration is 4 meter per second square. So this is our answer for our second problem. So we are in the third law of motion. So this one states that when two bodies interact, they apply forces to one another that are equal in magnitude and opposite in direction. So the third law is also known as the law of action and reaction. So as you can see in our photo, the first one, the swimmer. So the body is the system of interest, and then the direction of the acceleration is going to left. Okay? Now, if the feet of the swimmer is in the wall, now as you can see, this feet will put force to the wall para ma-push siya forward. And as you can see, the wall of the swimming pool will give also its reaction. All right? So for the second picture, we have here the ball. Kapag binagsak natin yung ball, so the floor will give a reaction wherein it will push the ball upwards. And for the third one, we have the gun here. And then if you pull the trigger, no, the gun will recoil force, and the action would be the accelerating force of bullet, okay, going out. All right. And then now we have a question here. So actions and reactions occur all the time. So here is another example. If we lean on something like walls or your locker, you are applying force to it. So the wall or the locker applies an equal and opposite force to you. If it didn't, you would go right through it, or else it would tip over. So that is the importance of the third law of motion, which is the law of action and reaction. Now, let us generalize the topic that we have discussed. So again, for the Newton's first law of motion, or the law of inertia, an object at rest will stay at rest, and an object in motion will stay in motion at constant velocity unless acted upon by an unbalanced force. Second, Newton's second law of motion, the law of force and acceleration. The net force of an object is equal to the product of its mass and acceleration. So our formula in finding force is m times a. In finding acceleration, we have F over m. No? And in finding our mass, we have F over a. And last, the Newton's third law of motion, or the law of reaction. For every action, there is an equal and opposite reaction.